Let's talk about mean as balance point and continue to try to understand mean at a deeper level. First, let's look at balance points in general. Here I have 3 blocks stacked on a ruler, and I've balanced it by putting my finger directly underneath the tower. As soon as I add more blocks on the left, then I have to shift my finger to somewhere in between the 2 towers in order to find my balance point. I'll end up with my finger in between the 2 towers, but closer to the taller tower to get the balance point. This is an imperfect representation of the balance points we'll be using because the ruler has mass and affects our results. Here we're going to use mean as balance point on this data. Each dot plot represents 20 students and their quiz grades. So this class quiz grade data, we can see on the top left, 1 student earned 5, another student earned 5, 2 students earned 5 on their quiz. 4 students earned 6 on their quiz, and so on. Each dot represents 1 student's quiz grade, and then we have 4 separate quizzes. When we look at the balance point here, again, assuming that our axis has no mass, we can see that we would put our finger directly under the 7, so I'm going to draw what's called a fulcrum right under the 7 to represent that as the balance point. If I calculated the mean by adding up each data point, 5 plus 5 plus 6 plus 6 plus 6, and so on, and then dividing by 20, I would see that the mean is indeed 7. On the top right here, we have another set of symmetric data, so it's fairly easy to see where to place my finger, where to place the fulcrum. I'll put it right here at 7.5, and if I calculated, the mean would be 7.5. On the lower left, it's a little trickier. I'd like to put my finger underneath the 7, but as soon as we had one data point down here at 1, I need to shift to the left. So I'll guess that it's somewhere between 6 and 7. When I calculate, I can see that the mean is 6.7. This last one is particularly tricky. One way to approach it is to look at the minimum and look at the maximum, and then go halfway in between and get to 6. And then think about if I put my finger under the stack that represents 6, what would happen? Well, it would tip to the right because we have more data points on the right, so I'm going to have to shift to the right here, and I'll put my fulcrum right here. The more of these that you do, and then check yourself with an actual calculation, the better you get at placing the balance point. In this last one, the mean was 6.7. Let's collect some real data, put our data on a dot plot, and try to estimate the mean using balance point. I'm going to answer the question, how many Unifix cubes are in a handful? As I take the handful, I'll create a tower, and I'll mark a data point on our dot plot. In the end, I had 14 total handfuls. Let's clean this data up just a little bit. Take a moment to think about where you think the balance point will be. There's a couple ways to go with this. One, I could see that my most frequent data point is 8, and so I could start there and then notice that I'll need to shift a little bit to the left to accommodate the rest of the data, and so put my fulcrum somewhere in the middle between 7 and 8 there. Another way to think about this would be to think about my minimum data point was 5 and my maximum data point was 10. Halfway between those, 7 and 8, I can see that if I put my fulcrum at 7.5, I have more data points to the right, so I should shift it a little bit to the right. If we actually calculate the mean, it turns out that the mean is about 7.6. There are multiple ways we can represent the data, and two of these can cause confusion for students. They get them mixed up. On the left, I've represented each individual data point as a bar, where the height of the bar represents the number of cubes in each handful. On the right, I have a dot plot, and now the height of the tower here, if you will, represents the number of data points. So this is not 1, 2, 3, 4, 5, 6 cubes. This is 6 handfuls or 6 data points. And this should be clear because we never had a handful with just 1 cube in it. Instead, we had 1 handful that contained 5 cubes. A subtle difference, but it's easy to get confused where the height in one side is the number of cubes and the height in the other side is the number of handfuls. So let's look and see where this gets us in trouble. If you like the leveling out perspective, where we keep the same number of groups but just even them out, then you want to work with the left, and you'll have a problem with if you work with the dot plot on the right. Let's look at that. So each tower represents cubes, and our total number of cubes, we have 106 total cubes. If I decide to take from the tallest tower 1 cube and relocate it to the shortest tower and continue to do that until my towers are fairly even or leveled out, I still have 106 cubes. Moving this cube over here didn't change the number of cubes, it just relocated them. So I can look at this, and after I've leveled out, my towers either have 7 or 8 cubes in them, so I know that my mean will be between 7 and 8. And this works because always I have 106 individual cubes and 14 total handfuls, and I'm just redistributing the cubes. Let's look at what happens if I try to do that on the right. So over here at the 8, I have 1, 2, 3, 4, 5, 6 different data points. And if I were to take the top data point and relocate it over here, where I only had 1 data point, that changes things. And let's see how. That's like taking this 8, crossing it out, and turning it into a 10. So now instead of 106 cubes, I have 108. So we can't just redistribute our handfuls like we did our cubes. We'll end up with an error. Another mistake comes in interpreting the height of the tower here, the number of data points, as the data point itself. So here we know that we have 4 different handfuls with 7 cubes. That's my 4 different handfuls with 7 cubes. But a student might interpret this as just 4 because they see the 4 dots. So a lot of times students will interpret this as 1, 1, 4, 6, 1, 1, and then they'll try to take the average. So that's adding up the height of each of my dot towers here, and then dividing by 6 because I had it with 6 total groups, ending up with an incorrect average of 2 1/3. It should be a red flag when you get 2 1/3 because our average should always be somewhere between the minimum and the maximum. And if we were to extend this down to 2 and draw a fulcrum, we could see clearly that's not the average because we would tip over to the right.